In this video, I'm going to go through 3 examples of simplifying radicals. In my first example, I'm working with the square root of 44b cubed c to the 4th. And just for this example, I want to show you that that is the same as if I were to separate this into 3 different square roots, root 44, times square root of b cubed times square root of c to the 4th. Because when you have common radicals, in this case each one is a square root, you can multiply them together and make it under one square root. Or, if you have it underneath one square root, you can separate it. You don't need to do this separating process, but I'm just going to do it to show you that you actually end up working with the square root of 44 individually, and then b cubed, and then c to the 4th. So when I'm looking at the square root of 44, I want to break it down into the factors of 44. I could choose 2 times 22, but neither of those is a perfect square. And since I'm dealing with square roots, I want to try and find a perfect square so that I can take that out of the radical sign. So I'm going to choose 4 times 11 because the square root of 4 is 2. So if I were just dealing with the square root of 44, my answer would be 2 root 11. But back here in this problem, this portion here, a 2 is going to come out of this radical, and 11 is going to have to stay in because it's not a perfect square. So the first part is 2 root 11. Moving on to the b cubed, technically I'm working with the factors of b cubed as well, which would be b times b times b, all inside the square root. And again, I have a perfect square in here because b times b is b squared. So b squared can actually come outside the radical as b, just like 4, which is 2 times 2, came out of the radical as 2. So technically you're looking for pairs of letters or numbers, and each pair, because it's square root, can come out as a single. So again, b squared is sitting right here, and so it's going to come outside as b. But this b is left inside because it doesn't have a partner. So this would be b root b if I were just simplifying the second portion. And then I could do the same thing with c to the 4th, which is 4 different c's underneath the radical, and you'll see here I have a c squared here and a c squared here, so technically 2 c's are coming out, which would be c squared on the outside, and there is no radical because the square root of c to the 4th is c squared. So here's my answer, but it looks really messy right now. I need to now group up everything that's outside the radical and everything that's left inside the radical. So outside I have 2b c squared, and inside the radical I'm going to be left with 11b. This is the answer to the first example. I have simplified this radical. My second example is working with the 4th root. So unlike the square root, I can't find perfect squares. I actually need to find things that multiplied by themselves 4 times will equal the numbers inside. I'm still going to work with the factors of 32, but now I want to break it down in a way where I could take the 4th root of one of those factors. So if I break it down to 16 times 2, I can actually find the 4th root of 16. The 4th root of 16 is 2. So this is going to come outside as a 2 and not be in here anymore. This 2 has to stay. Again, you could have broken that 32 down to 5 different 2's and then said, here's a group of 4 of them. Since it's the 4th root, these 4 would get to come outside as 1 2, and this 2 would have to stay. However you want to think about it. Moving on to the x's, I technically have 5 x's in here. X to the 5th is x times itself 5 times. So I could rewrite that as x to the 4th times x. The reason that I chose x to the 4th is because the 4th root of x to the 4th would be x. So this x to the 4th is going to come outside as an x. Okay, I'm just going to group that over there. And then this x has to stay. Now, looking at the y variable, I only have y cubed. And since it's the 4th root, I'm supposed to have 4 of something in order to be able to take it out of the 4th root. So y cubed actually just has to stay. I can't do anything with that. All 3 of them need to stay. Z to the 8th, however, I could break down to z to the 4th times z to the fourth. And that's two groupings of z to the fourth, which means, since it's the fourth root, that this z to the fourth can come out as a z, and this z to the fourth can come out as another z. So that's two z's sitting out here. So we have x times 2 times z times z. Sorry, this is really messy. And so outside the fourth root, if I just said square root, is 2xz squared, and left inside the fourth root, we have this 2, this x, and this y to the third. So all of that needs to stay inside. So this is your final answer of the simplified radical. In this third example, I'm multiplying together two radicals that are different. So I have the square root of y times the fourth root of y cubed. So I cannot multiply these together as they stand. Instead, it might be helpful to rewrite them using fractional exponents. So instead of the square root of y, I'm going to rewrite that as y to the 1/2. That's the same thing. And instead of the fourth root of y cubed, I'm going to rewrite that as y to the 3/4. And now I'm multiplying common bases, and when I'm doing that, I get to add exponents. So I should be able to add 1/2 and 3/4, which I can. I first need to get a common denominator though, which would be 4. So this would be 2/4, y to the 2/4, times y to the 3/4, and that together, when I multiply those bases together, I get y to the 5/4. I'm okay with you leaving it like this. However, you could technically rewrite this as the fourth root of y to the 5th, and then you'd have to go through your process of simplifying this. Okay, so you might want to just leave it like this for now. But technically, the fourth root of y to the 5th is the same as the fourth root of y to the 4th times y. And again, as I did in the previous example, I chose to separate it this way because now I can take y to the 4th out of the fourth root, because the fourth root of y to the 4th is y. So this is actually y times the fourth root of y. So either of these answers is acceptable. That's it. If you have more questions on simplifying radicals, send me an email.